Hi, hello, welcome to Knowledge Center. As by looking into the thumbnail, you might have already got an idea that I'm going to explain you about the basics of programming in a microcontroller language. According to my previous videos, you might have got an idea about what is the microcontroller, its architecture, and all the basic informations which is required to be known by an engineer before writing a program. Before going to a programming concept, I just want to make you perfect with the basics of programming, that is what is the directives and how the instructions has to be written and what are the labels we are going to use here. So in this session we will have an in detail idea about all these things. So let's begin the session, and one more request are, if you have understood the previous concepts, then kindly subscribe to this channel so that you can get the notifications of new videos whenever I upload it here. Okay, by this note I just want to begin the session today. So basically we will have a question that what actually the meaning of programming language. So what do you mean by that programming language? We all know that language is nothing but it is a way of communicating with the other person. So here in programming language we can say that that is the language is nothing but that is a way of communicating with the system or with the processor. Okay, so but how we are communicating? We are communicating in a sequence of instructions. We are communicating through our instructions that will be written in a sequence, and they are going to be executed by the processor, that too in a systematic order, in a particular order. And why you are going to execute all these things, and why you are going to write the instructions? To perform a particular task. So this is how we can define the programming language. A language which is written in a sequence of instructions and that is used to execute a particular task, and this execution is done by a processor in a systematic order. So this is how we can just define or phrase the meaning of a language. And when we talk about languages, there are three types of languages we have. Basically, that is the machine language, assembly language, and high level language. Nowadays, most of the high level languages have been studied by the engineers. And now in this microcontroller is, now you need to understand that microcontroller, whether it is a machine language, assembly, or a high level language. So before that, let us understand what is the machine language. The machine language indicates that machine, the name itself indicates that the language which is suitable to be understood by a machine is called machine language. Okay, means it will be easier for a system to understand the instruction, but definitely it will be not easy for a user to understand it. Okay, so you can say that lowest level of programming is known as the machine language, because it is almost closer to the machine, means the programming will be, the instruction sets will be written in binary patterns. So this is major thing you need to understand here. We make use of zeros and ones to write a program. If you want to write a letter called A, you have to write it in terms of zeros and ones. So it will be easy for machine to understand this, but for a user it will be difficult, because just for one character you have to write zeros and ones. If you want to write a name, if you want to write one paragraph, then it will be a huge task. So that is why we can say that this is not an user friendly. Here you can see the combination of binary digits will give you a set of instructions, set of programs, and this will be stored in as a high and low voltage levels. Okay, so this is about the machine language. You just need to understand one thing here. Machine language is nothing but the language which is easy for a machine to understand. That's why it is called machine language. So in other words, you can say it is not so easy to understandable by the user, a bit complicated for a user to understand it. So we got the very next one, that is the assembly language programming. See here, they have made some slight changes here. They utilized a pseudo English concept. Pseudo English concept is nothing but similar to the English, but not exactly the English words. They write a program, they use the instructions which are in English language. Okay, pseudo English will represent the machine language here, and it's a combination of English like words. See, this is important. It's like English words, but not exactly the English word. For example, we can take one instruction here. We have an instruction called move, but in English we name it as a move, we spell it as a move. But in microcontroller, in assembly language, we just write it as mov. So these are English characters, letters, but not exactly the word way you write in English, right? So that's why it is called pseudo English. It is also a low level language which is easy for machine to understand. Okay, but the thing is, a small change has been done, that they are going to make use of an English like words but not zeros and ones to write instructions. But here one thing you need to understand: if you are writing a program in assembly language, you need to have a huge understanding of a architecture of that particular microcontroller. While means you need to have an idea of a hardware architecture of microcontroller. You need to know what actually the size of memory we have, what is the processor we have, what is the how many inputs we have, how many output ports we have. You should know all the things, then only you can write a program here. So it means that you need to understand the machine completely, then only you can write a program. So that is why it is not called as a high level language, because you need to study about the machine, so it is termed as a low level language also. Then we have high level language. So these are the language which are very famous and widely used, right? But you may have a doubt that if high level languages are used widely, why we are using that assembly language now? So I'll come to that point later. Before that, let us understand what is this high level language. So high level language is nothing but what? Easy to learn. That is one advantage. I have just mentioned some few points here, advantages. See, you need not to worry about the architecture. See, this is one point you need to understand here. For example, see, we have an examples here: C, Pascal, Java, C++, Basic C. These are some of the examples of a high level language. Whenever you study the C language or Java and all those, we will not be bothered about the architecture of that language, architecture of that hardware. So no need to understand the architecture or any internal details about the system. That's why it is easy to learn, means you can just understand the instructions and addressing modes, then you can write a program. Okay, that is why it is easy to learn. So it is also called as user friendly, because the words which we are going to use, the instructions which we are going to use here, they are like an English statement, so humans can understand it easily. If you want to print something, then you can write print f. So this is what the instruction you can recall which we use in a C language. So this is the English word, so it is easy for an human being to understand it. Okay, that's why we can say it is user friendly. Next we can say there we required a compiler which is going to convert the program written in high level language to machine code. See, this is where we have one major issue. We need to convert that high level language. See, print is understood by a user, but machine will not understand this print word. It has to convert this into low level language, that is machine language. Okay, so you should convert that into binaries, zeros and ones. So for that we need a converter which is going to be a costly. So that is the way major drawback we have in a high level language. Okay, and also this processing time is going to be high compared to the low level language, because it has to convert this into a machine language and then it should execute the program. So definitely the time taken by high level language will be slightly greater than the assembly or a machine language. Okay, this is the major reason why even now few industries are going with an assembly language programs. Now let's see why we have. So this is what the thing I was talking about, why we are going for an assembly language. Even though we have C and high level languages, still in V2 syllabus we are studying the assembly language, that is microcontroller. It's because we can direct and accurately control of resources. We can control the resources, means you will be having an idea that what is the size of RAM, what is the size of ROM, and how to use it, how to control it. You will have all these ideas, right? So, and we can access it directly. That is the main advantage we have, because we will have an hardware idea. So we can say that we can access the data directly and we can control them accurately. And next thing is execute faster and occupy less memory. This is what I was talking about in the previous slide. we can execute faster because we are writing the program already which is easily understandable by a machine. Okay, so no need to have any converters here, directly it will execute it, so the speed is going to high, execute faster, and the memory will be less because we require less memory because we no need to convert the high level language into smaller level low level language. So for that we no need to store it, that is why it is called as it is going to occupy less memory. And for execution we use very less number of clock cycles, that is an advantage. And also the number of rules and restrictions are going to be less, we need to have a much rules and restrictions here because we are going to have a very reduced instruction sets. Because of all these advantages, still we are making use of an assembly language programming. Now let's see what is the structure of this 8051 assembly language programming. When you write a program, there must be a set of instructions and a structure. So this is the basic structure of any instruction. See, we can have a label. See, this is in a square bracket. Label has been written in square bracket. Observe this. And even comment is mentioned in a square bracket. Whereas this instruction we don't have a bracket here. So bracket indicates that this is an optional. You may have the label or you may not have it. You may have comments or you may not have it. This is option. But whereas the instruction is mandate, you need to have this instruction in the structure. Okay. So to understand this, I have given an example here. Look at this. Test label colon, and we have one instruction. This is instruction here. You can look at this picture. This is instruction as I mentioned here. This is instruction. This is the label which I have used, and this is the comment which I have written here. So comment is just for an understanding purpose. By looking into comment, any other person can understand the instruction, what that instruction is going to do. So here in this comment I have just mentioned that this is a sample. It's for a sample comment. So you can say that move a comma 24h means what's happening here. You can write that part here, like the content of 24 will be given to a. That's what you can write it here. So by just reading into this comment, a person who don't know what is actually happening here, even that person can also understand that what's happening in the instruction. So this is optional. So whenever you write a semicolon, whenever you put a semicolon, after that whatever you write, that will be considered as a comment. It is not going to be executed. Only this portion is going to be executed. Okay, so that is important. So after semicolon, whatever you write, that will be a comment. Okay, and for a label you have to put this colon. So let us understand this portion now. What is this move A24? What we call it? Let us have an in detail idea about this. This is just about a structure. So in this structure, instruction is mandate, whereas label and comments are optional. We get this in only few instructions. Now, before moving to I was telling about this. So before moving into this instruction, let's see one by one about label first, then instruction, then comment. Comment is a general thing which I already told you. So first understand labels. So the label is nothing but what? That is just for that is a name, means that is a name given for that particular line. If you want to jump to that line, you can call that label. Okay. So there are some fixed rules for writing a label. The label must be started with a character. This is a very first important rule. Means if you want to write a label, that label may be anything. You can just write a label called next, like this. This is see in the previous slide. You can look at this. We have taken it as a test label. That is the name we are given for the label. Same way here I have given next as a label name. So the very first, this has to be a character. It has to be a character. Means you cannot write like this. You cannot take one next. So this cannot be a label. This is invalid. So it cannot be started with the numericals. That is one point you need to understand. So it has to be a character. Okay. I hope it is clear. Now next point is, it is a case sensitive. See, whenever you are calling this, when you use the next, wherever you are calling that label, there it should be of a same case. Means n if you are used as a capital letter, it should be in a capital only. Next, if you are used a small letters, then it has to be a next letter should be small. So case sensitive, you should be very careful about it. So you can understand about this label, how we are going to make use of these labels in a program in the very next video. In next further videos I will explain you how the labels will be utilized. Now just understand how it has to be written. These are the case sensitive, and the first letter should be a character. Then third point is, you cannot make use of an instructions or directives or anything which are relevant to the microcontroller register. This is major important. So once you read the architecture, we know that R0 to R7 are the registers, R0 to R7 are the registers. You cannot make use of these registers as a labels. As for example, say MOV. This is the instruction. And here if you look into this first point, it is starting with a character, right? So but the thing is, this is an instruction which cannot be used as a label. So you need to be careful about it. Instruction or any directives or anything which is related to the microcontroller registers cannot be used as a label. Even though those are they are satisfying the first two conditions, you cannot make use of this as a label. Okay. And next last point is, the label must be terminated with a colon. That's what I told you. Even you can look at it, the previous slide here. It has been terminated with a colon. Here you can see that label, and it should be terminated with a colon. If not, it will be invalid. So while writing a label, you have to follow these 4 steps carefully. So you can understand that when we start writing a program. Now before moving to the programs, now let us see what is the instruction. So instruction will have a major concepts, that is opcode and operands. Okay. So we know that these are the theory point I have written. It is responsible for performing the task, and it consists of 2 important parts. One is the opcode and the other one is operands. So in this instruction we are splitting it into 2 parts, opcode and operands. Op is nothing but operational code, and operands. Okay. So move is a opcode, whereas A, 22 are the operands, and these operands are splitted into 2. This is called as a destination operand, whereas this is the source operand. So when you write this kind of an instruction in microcontroller, it operates like this. It will be operating in this direction. Means whatever you have at this 22H, that will be moved to accumulator. Here look at the command, move 22H to accumulator. That's what's going to happen here. So we are giving the content of 22H to accumulator, means this is going to become a source. So that is why we named it as a source operand. Whereas accumulator is receiving the data from 22H. So this is the destination. The accumulator will become a destination operand. So any instruction should have a operands and a opcode. In some instructions we can have 2 operands. In some of the instructions we will have only 1 operand, and some of the instructions are there where we can also have 3 operands. So further, when we deal about the instructions, there we can have in detail idea about the operands. Okay, I hope this is what the idea you got about the instruction. There must be a opcode and a operands. Okay. Now let us understand about directives. So we studied about the labels and instructions, and in a program we also need to have a directives. So what are these directives? See, in assembly language, directives are not the instructions. First highlight this point. Those are not the instructions. They are not going to be executed, but they are directing the processor. Okay. And also they directs the assembler program. They are just directing the assembler program, but they are not going to be executed. So then what is the use of it? Let us understand. So the directives are of 5 types. First let us see this, and one by one we will understand what is the use of all these directives in a program. The very first one is the ORG. Then we have equate, EQU, DB, define byte, then DW, that is define word, then END, end. So let's say what is ORG. See, ORG here we have written, and the syntax is ORG, and it should be continued with the address. We have to write address here. So whenever we write a program, the program has to be stored at some of the location. So when you write like move instruction, when you write this move A, 10H, right? So when you write this program has to be stored somewhere, right? So where you need to start to store the program, that will be defined by the ORG. So before writing a program, the very first line of the program should be ORG, and it has to be followed with a number address. So when you write org0000h, it means the next line what you have written here, this instruction will start storing from this location. Okay, so this is just directing a processor that the program, whatever the instructions we are writing after this line, those has to be stored from this location. So you can take org0000 or you can take org any other number, but that should be lying between 0000 to what may be the maximum, that is f f f f. So this is the maximum address what we can give. Okay, so we can say that this is just used to direct the processor to start from that particular location. That is how we are going to make use of an org. So I hope it is clear for you that why org is used. Every program should start from this, and org stands for origin. It is giving an originate address for the system to store the program. Now let's see what is equate. EQU. So it means equate. You can take an example here. So equate is nothing but we are equating some numerical value to some characters. Here I have taken TMP equate #30. It means we are assigning this 30 to TMP. And in further in a program, wherever we want to have that 30 in a program, we can just write TMP. Then TMP is nothing but what? TMP itself is TMP is assigned as 30. So wherever we use TMP, that is nothing but it is 30. So instead of writing 30, we can just write TMP. Here we have another example. Instead of writing P1.0, we can write RED LED. Okay, we are defining that to a particular label, a particular name. Defining some number to a particular name and equating that to a particular name is called equate directive. So we are just informing the assembler that the number 30 is assigned to a TMP. So wherever we use TMP, it's nothing but it is 30. Okay, you will come to know about the usage of this when we write a programs. I'll just explain. I'll just give an example. Let's say there is a program wherein we have to change this 30. Say you may have a question that why should I use this TMP instead of 30? Directly I will write 30 in the program. So I'll tell you one thing. Assume that there is a program which is having of 100 lines. 100 lines of instructions we have in it. Okay, and among in this program, say there is 25 lines where I have used. Assume that there are 25 lines where I have used this TMP, means 30. Now I want to change this 30 to some other number like 40. So if you want to change this, instead of changing in the 25 lines, if you equate it to TMP or some other name, you just make this TMP equal. You just change this one particular line. Here you make it as 40. Then instead of in this 25 lines wherever you used TMP, that will become 40 automatically. You need not to change the 25 lines. If instead of TMP, instead of equating, if you have taken the 30 in these 25 lines, then you have to replace all 25 lines by 40. Now what I have done, instead of that, if I equate it to some other word, then by just changing this one equating condition, instead of 30 we will just make it 40 here. By just making that, you can just change all the numbers in that 24 lines. Okay, that is how we can make use of this equate in a program. Now let's go for the another directive. This is a define byte directive, and this is an 8-bit directive. Okay, you can define any number if you want. Like in the previous one we had only one number. Now here decimal, binary, hexa, ASCII, anything you can define. So how to define? Write org00. After that you write db10. So if I write db10 is nothing but define byte 10. Okay, and I have not written anything here. So it means that this is going to be understood as a decimal. System will understand that it's a decimal number, and where it will be stored? It will be stored from this address 0000. After that, if I write db30h, so 30h will be stored. It will be hexa number, and it will be stored in the very next address, that is 0001. No need to mention that address here. Okay, so you can store the characters like this. You can store the binary number, but the thing is you have to mention it here, b, and character has to be given in the double quote like this. Okay, then only it will be understood that it is a character. So these are again to define some of the numbers or some of the characters at particular location, right? So you look at these addresses here. After 1, this string will be stored from 2 to 7, because s will be stored in 2, 3, 4, 5, 6 and 7. So 7 locations are used to store it, 5 locations are used to store it, that is from 2 to 7. So after that, if you write db binary numbers in b, and these numbers will be stored at next address, that is 8. Okay, so these are just the things. And last one, you understand about this thing, db1234. Here I have written 16 digit number. I have given 16 digit number, but what happens, define byte is going to deal with only 8 bit. So here it will store only 8 bit number. So understand one thing, when you write 16 bit number, the processor will understand only the lower 8 bit. It will take only 34. See, 34h will be taken. It is h, so it will be read as an x number. It will store 34 in the very next address. Means previously it was 8, now it will store it in 9. But 1, 2, the 12 will be missed out because it is an 8 bit. Means you cannot store the 16 bit number in this. So to avoid that, we have another defined word, another directive which is called define word. So here we can store 16 bit data in a program, which was not possible in the define byte. So this define word is used to store the 16 bit data in a program. Now the last directive is end. This is the most important directive. Means after completion of the program, the processor should come to know that yes, we have to stop it here. So to do that, we have to write just END. So there are some rules here. This is the last, the end directive is used to stop the assembly process, and this should be the last statement in the program. So after END, whatever you write, it will not be executed. That is one thing you need to understand. Okay, unless and until you jump to that line, it will not be executed, right? And end directive cannot have a label. There must not be any labels in that. End should be a very one special line which should not have any labels. Okay, the statement beyond end will not be processed by the assembler. That's what I told you. After end, whatever you write, that will not be executed. So this must be a last line of a system. Now I hope you got some of the idea about the directives and what are the labels and instructions. So these things can be understood easily when we start writing program, when we start applying these things over there. So don't be panic if the things are not clear till now, because you cannot become a master by just looking into a one class. You need to apply these concepts, then only you can become a master of the language. So I am definitely going to make you this concept easy, and you can understand microcontroller. You can write a program, but you need to follow the videos what I am going to upload, and read and understand the things what I am going to explain here. And also it will be easy for you only when you start writing program. So after 1 or 2 videos, I am going to start writing programs using the instructions and all the parameters what we have studied here. That is using directives, using instructions, using labels, using commands. We will write a program, and there you come to know how we are going to make use of all these things what we have studied here. Okay, so this is an example, one simple example of writing a program. So the program has to be started with the org and some address where the program has to store. So move A. So here what happens, the content of 20h will be given to A. We don't have label, so I told you label is an optional. So we don't have label here, and even I have not written comment, just one instruction I have. So this is called opcode, these two are called operands. So remember these things. 20h content will be given to A. Next 30, so this is an immediate addressing mode. So to understand this, we need to know addressing modes. So I will take up this concept in the next class. Okay, so be active, and not only subscriptioner, you need to press the bell icon and make it all. So when you select that bell icon, then only you will get the notifications of my new videos. Then you cannot miss any videos of mine. Don't miss this session. In this addressing modes, you will come to know what are the way of writing these instructions, what happens here and what happens at this line. You will come to know the difference over there. So this is just a sample of program that written 2 instructions, and then lastly we written end. So don't forget, the very first line of a program should be org and with address, and last line should be end. This is how the syntax is to be of a program. I hope the basic concept of this has been clear for you. If it is so, like and also put your comment about the video, and also you can share your thoughts that what kind of video you are expecting from my side regarding microcontroller. I hope you can do that. You will do that.